Video, we're going to talk about slope and intercepts. We're going to start off with intercepts, though. And so we're going to have some definitions to go through and then an example, and then we'll move on. So an x-intercept is a point where a graph touches or crosses the x-axis. And I'm going to emphasize point in both definitions here because an intercept is a point. It's not a number. It's not an equation. And if we're touching or crossing the x-axis, the y value has to be 0 in that point. Hence the point a comma 0. With the y-intercept, it's where the line or graph touches or crosses the y-intercept or the y-axis, and that is 0b. If you look off to the right here, I have two pictures. I have a line, and I use multiple colors on that. The y-intercept is labeled at 0b in red, and in blue I have the x-intercept a0 because the line crosses the respective axes at that point, at those points. The other picture is a parabola. You might recognize that from previous math classes. We'll be talking about those in detail. Graphs of equations or functions, which we'll explore a lot in this class, they can cross axes more than once. And in this case, I have two x-intercepts and a y-intercept. So finding intercepts, oops. We're going to use a definition to help us find intercepts. So for example, consider 3x plus 4y is 9. This is a line, equation of a line that's in standard form. And if you recall from the definition, for my x-intercept, the y value is 0, and for my y-intercept, the x value is 0. So if we plug in the opposite coordinate for 0, we can always find intercepts. So for my x-intercept, we're going to set y equals 0. We're going to evaluate that. So it's 3x is, oops, that's plus 4 times 0. That's 9. 3x is 9 because 4 times 0 is 0. So 3x divided by 3 is 9 divided by 3. And that gives me my x value is 3. And so my x-intercept is 3, 0. And that's all there is to that. The y-intercept is going to be very similar. I'll plug in x equals 0. So 3 times 0 plus 4 times y is 9. That gives me 4y equals 9. And when I divide both sides by 4 here, I'm going to get a fraction, and that's okay. So 9/4 is my fraction for y, and that gives me, oh, I'm going to fix my x-intercept up there. I'm sorry about that. So my y-intercept is 0, negative 9, or I'm sorry, 0 9/4. So whenever you're asked to find an intercept, you plug in the opposite value, 0. And so for x-intercept, it's y equals 0. For y-intercept, it's x equals 0. And that's the case all the time. For slope, let me draw a quick picture here. Say I have this line going through the x and y axes. And I have 2 points on that line. So the way we think about slope is we're going to count off how far the graph is rising over how far it's running. So you might have heard rise over run. And I'm just going to stick with one color here. This is going to get messy. So I'm just going to stick with one color. And to compute the rise over run, we're going to take the difference in the y's over the difference in the x's. And so it's going to give us this formula where m, we use that to represent the slope. That's y2 minus y1 on top, x2 minus x1 on the bottom. And this formula, we're going to have to commit to memory. This is the slope formula. So let's see a couple examples. Well, 3 examples I have in mind. So we're going to compute the slope between the points -2, 4 and 3, 3. So what a lot of people like to do is they like to assign the values, and it doesn't matter which way you plug in the points. Just do it correctly. X1, Y1, X2, Y2. And again, it doesn't really matter which order you pick, as long as you have X1 and Y1 together and X2 and Y2 together. So what I'm going to do, once I get my points assigned, I'm going to write my formula down. M is Y2 minus Y1. The Y's are always on top. Rise over run. X2 minus X1. And I'm going to plug the values in accordingly. So 3 minus 4, Y2 minus Y1, and 3 minus a -2. The formula has subtraction in there because it's a difference in the x's and difference in the y's. So make sure you're paying attention to your signs. So 3 minus 4 is -1. That turns into 3 plus 2, which is 5. So my slope is -1/5. I'm looking at the points 2, 5, and 4, 5. You can assign either order you want. So I'm going to do X1, Y1, X2, Y2. I use my formula. We get 5 minus 5 on top, 4 minus 2 on the bottom. That's going to give me 0/2. And my slope is going to be 0. And it is possible to have 0 slope. There's no problem with that. And I'll show you some pictures of what the different types of slopes look like in a moment. But before we do that, let's continue on for the last example. So I'm going to look at the 2 pairs, -3, 1 and -3, 6. And just because I said it doesn't matter, I'm going to change the order in which I assign. So looking at these 2 values, I'm going to use my formula. You notice I'm writing down the formula every time I use it. That's actually intentional. If I write down a formula every time I use it, it helps me remember it easier. It actually just happens naturally. I don't have to memorize it. It just becomes a habit. Really helpful for tests. So let's see here. My Y2 is 1 minus 6. and -3 minus -3. Now we get a -5 over 0. And wait a minute, division by 0, that's not possible. We call that undefined. And it is possible to have an undefined slope, and we're about to see some pictures. So there's 3 examples of how to compute slope. So here's some rough pictures. A positive slope moves up as I go from left to right. So positive slope. A negative slope goes down as I go left to right. So if you're looking at graphs of lines and you notice that things are going up as they go to the right, then that line has a positive slope. If it's going down as it goes from left to right, that's a negative slope. So be a little more careful in this one. So if I have a line that goes straight across horizontally, that's 0 slope. So m would be 0 for the line that looks like that. And finally, slope lines that have a slope that's undefined, those are vertical. So there's 4 types of lines that you can have here. Positive, going up as you move to the right. Negative, going down as you go to the right. 0, which is horizontal. And vertical, which is an undefined slope. So we're going to talk about slope-intercept form. This is a very special form of linear equations. It's arguably the one that gets used the most in most algebra classes, and a lot of students think that this is standard form because they see it all the time. But it's not quite, and we'll talk about why. And that form is y equals mx plus b. And we've actually used this already in this class. I didn't tell you that's what it was, but that's what it is when y is by itself, and you have mx plus b on the other side, that is the slope-intercept form. It's called that because there's our slope, and the b value is actually the y coordinate from the y-intercept, and hence its clever name. So using slope-intercept form is useful for graphing because we can say y depends on x. We can plug numbers in. We can also use it to count off slope. So we'll probably talk about in class, graphing with this form. Just to keep this video short, it's something that's better demonstrated in person anyway. So if I am given a slope and a y-intercept, I can come up with an equation right away. So if I have a line with slope 1/2 and passing through 0, 4, let me rewrite that. That's the word the. So write the equation on the line with slope 1/2 passing through the point 0, 4, which is a y-intercept. Well, m is a number in front of x, b is a y-intercept. Well, the y coordinate of the y-intercept. So y is 1/2 x plus 4. So if you're given that information, you can come up with the equation of a line very quickly. When you're looking at lines in standard form, Real quick, I want to talk about why that's the case, where ax plus by is c is in standard form, yet y equals mx plus b is not. And that's because of an undefined slope. We can't plug in undefined into that formula here. It turns out that vertical lines they have the equation of x equals a. And it could be a positive number, negative number, 0. It doesn't really matter, but there is no y coordinate in there or no y value because this does not depend on y at all. So if I look at the equation of x equals 3, I were to draw that picture, the x coordinate is always going to be 3, and the y value, it's going to take on whatever y value that's passing through that, which is every single one. So this doesn't depend on y at all. You cannot put this in slope-intercept form. So it's a whole class of lines that's not covered. On the other hand, horizontal lines, since we're talking about special cases, we're talk about this quickly. Let me write that more clear. Sorry about that. They're in form y equals b. And if I would draw that picture, let's use red. So that is, let me draw that a little bit neater. My pen, well, my hand is not cooperating today. There we go. I like that better. So if this is y equals 2, I get 3, 2, 0, 2, negative 3, 2. It doesn't matter what my x value is, my y value is always going to be 2 in this case. So that would give me a horizontal line. So this is in standard form with m equals 0. Y equals 0 times x plus 2. So technically speaking, that is in, or not standard form, this is in slope-intercept form. And so, you know, horizontal lines are cool with slope-intercept form. Any other line with an angled slope is cool, but the vertical lines are not. So since an entire class of lines is missed by slope-intercept form, it can't be a standard form. And let's see, I think that's it for this video. We're going to talk about more general equations for lines in the next video.